Alright, welcome back to class. So let's continue with conversion from order basis to base 10. And that's number 4 question. From graph 11011 base 2 to a denary number. We have options here: 16, 24, 26, 27, 31. A, B, C, D, E. All in base 10. Don't forget, denary means what? Base 10. So take note. Can do that for me. Take that. Convert 11011 base 2 to a denary number. Don't forget, I said when we are going to base 10, we start with putting degrees on top of this number. Please, from the right to the left. Don't forget. If there's still another degree, I'll put 5, 6, until there's no more degree. So please, from the right to where? The left. It's just like a turning number line upside down. As a matter of fact, 0 to the left in number line is negative number, so you see. Then 0 to the right, you will see positive number. Then here now, it's as if I'm inverting, I'm turning number line upside down. So in this place now, it's from right to the left. And I put 1, 2, 3, 4 until there's no degree again. Okay, let's go. 11011 base 2. So take the first degree, multiply by what? The base. Don't forget the base. Raise to power the power. It is that base that is carrying the power, not the number. We only just put the power here for us so that when we are dealing with 1, that's when we use power 4. Plus, take the next one. 2 raised to power 3 plus digit 0 multiplied by 2 raised to power 2 plus digit 1 multiplied by 2 raised to power what? 1 plus digit 1 multiplied by 2 raised to power what? 0. Please, it is the base that is carrying the power that you put there earlier. Now, 1 times this first one, I'll be open to you. This first one. 2 raised to power 4 should not be mistaken to be 8. 2 raised to power 4 is not the same as 2 times 4. So 2 raised to power 4 means 2 times 2 times 2 times 2. So take note. Now 1 times 2 raised to power 3 is what? 8. By now you know what I'm doing. Because that is 2 times 2 times 2, that's 8. Plus 0 times anything is what? 0. Plus 1 times 2, 2. Plus 1 times what? 1. Any number raised to the power of 0 is what? 1. So here I'm having 16 times 1, 16. 8 times 1, 8. 0, not useful. Plus 2. 1 times 1. 1 times 1 is what? 1. So we have 24, 26, 27, base 10. I'm calling it together 27 because I am base 10. If you are not in base 10, you have to call the number degree by degree. So, correct option? Option D. So we are correct, option D. Okay. Now, what of cases involving decimal point? So please, you are seeing, when we are converting from base 10 to other bases, we will be dividing by the new base. When we are going from other base down to base 10, we will be multiplying by the new base. Okay. Cases involving decimal point, I'll just put 1 there. It's not really a serious thing. Cases involving decimal point. I'll just put a question on that, and that will be my number 5 question. Convert 10.1001 in base 2 to base 10. Convert 10.1001 in base 2 to base 10. Take note, I have not said 10.1001. No, it's not 10 point. It is 10.1001 in base what? 2. I'm asked to convert to base 10. So, what we did the other time we're still going to do. I put 0 here and I put 1 here. If I take other digits to the left, I'm going to put the power there. Now, don't forget I said what was there is like a number like turned upside down. So after 0 here is going to be -1, followed by -2, -3, -4. That means 1 will make use of -1, 0 will make use of -2, this 0 will make use of -3, and this 1 will make use of what? -4. Let me make it clear. -1, -2, -3, -4. Okay? Now, let's go now. So, 10.1001 is going to be, take the first digit, multiplied by the base we have. We are in base 2, we are going to base 10. Multiplied by the base we have. Okay, so if you are converting to base 10, it is the base you are coming from that will be used to multiply. It is the base you are coming from that will be used to multiply. Is that okay? So since I have base 2 here, I'm going to say 1 times 2 raised to power 1 plus 0 times 2 raised to power 0 plus. Please, when you are dealing with the work, you will do it with decimal point. The negative power has made us to know that there is a decimal point here. Plus 1 times 2 raised to power -1 plus 0 times 2 raised to power -2 plus 0 times 2 raised to power -3 plus 1 times 2 raised to power -4. This is 1 times 2, quite alright. This will come to 0. This is 1 times R under indices. This will be 0. This will be 0. This is 1 times 1 over 2 raised to power 4. Please, I have just applied the law of indices in this place. When we have a negative power in indices, we have to do away with that negative power by putting the entire index under 1. So 2 raised to power 1 is coming under 1. So the 1, if it's there, is going to make any difference. That's why I didn't put it in the first place. So 2 raised to power 1 will come under 1. The moment I've done that, no more negative power. Now, this one will have been 1 over 2 raised to power 2. This will have been 1 over 2 raised to power 3. And that's why this one is what? 1 over 2 raised to power 4. The 1 has helped me to take care of the negative. So when I put this index under 1, I will put it without what? Negative. Because the 1 on top is taking care of the negative. So 1 times 2 is 2. 0 is not going to work. 1 times half is half. 0 will not work. 0 will not work. 1 times 1 over 3 raised to power 4. 3 raised to power 4 is 16. So that's 1 over what? 16. So I'm having 2 over 1 plus the 1 over 2 plus 1 over 16. I can add everything together now. Look for the LCM. 1 and 16 is 16, right? 16 times 2 is 32. 2 and 16 is 8, right? 8 times 1 is 8. And 16 and 16 is 1. 1 times 1 up is 1. Okay, so I have 41 over 16. 41 over 16. Now 16 will go in 41. How many times? How many times? It will go 2 times. And that's 2 times 6 will be 32. So I have remainder what out of 41? I have remainder 9. All over what? 16. Now, I forgot to put the option. We have 2 9 over 16. We have 2 5 over 16. We have 2 1 over 16. We have 2 3 over 16. We have 2 7 over 16. A, B, C, D, E. So the correct option here is option what? Option A. Option A. So after now, we now want to see how to add, how to subtract, how to multiply. For now, we may hold on to division part. When you get to SS1, that will be, it will be easy for you at that moment. But as a matter of fact, there's nothing really serious about it. The fast method of doing that is that if you have to do division, whatsoever base you have, convert all the bases to base 10. You can easily divide when you are in base 10, normal division. So after you have divided, you can take your answer back to the base in question. Okay? Let's take a step further. So take note that it is when we have, what is it called? When we have decimal part, that negative powers will come in. When we have negative decimal part, that's when negative powers will come in. And quickly, if I'm going from base 10 to base 7, I will divide through by base 7. But if I'm going from base 7 to base 10, I'll be multiplying by what? 7. If you are going from base 3 to base 10, you'll be multiplying by 3. If you are going from base 5 to base 10, you'll be multiplying by 5. If you are going from base 9 to base 10, you'll be multiplying by 9. But if I'm now coming from base 10 down to other bases, that's when I'll be dividing by the new base. Alright, let's see addition and subtraction. Addition and subtraction. Addition and subtraction. So let's look at this question. That will be our number 6. Add in binary. Add in binary, that means in base 2. 1 1 1 and 1 1 1 1 in base 2. So we set out our addition. Normally, let's take the longer one, 1 1 1 1, and take the other one now, 1 1 1. Then we are asked to what? Add. We're going to see the solution to this in the next clip.